Okay, students, Assalamu alaikum. We will continue where we left off last time, which was the concept of rotating magnetic field in the induction motor. So we are going to do a derivation. It looks a bit tedious, but when we look at it closely, it is actually very easy. Basically, we just revise a little bit. So we were studying about the induction motor, and we said that there are three set of coils. So you can think of the stator having three set of coils. Okay, so one set of coil could be like this. Like this is the current going in, this is the current coming out. So half of the circle is outside the page and half is inside the page. So if we have the direction of current like this, if we use the right hand thumb rule, so we basically find that the north for this set of coils will be on this side and the south will be on this side. So now imagine if we have three set of coils, one is placed like this and another is placed like this. So we'll be having a three set of north south poles, but the difference would be as the three phases are fed with different 120-degree phase difference. So let's say this is the first phase, and let's say this is the second phase, and let's say this is the third phase. So all of these phases will contribute to magnetic fields which are oriented 120 degrees apart, which are oriented 120 degrees apart like this. So this is the first set of field. This is the second set of field which is lagging it by 120. Lagging means when this set of coil will reach its peak in one direction, the other one will also reach its peak in after a difference of 120-degree angular separation. And this is the third set of coil. It will reach its peak after a further 120 degrees or 240 degrees lagging behind the first one. So this is the three set of coils, and at different points in time, this diagram will not look like this. Obviously, the resultant magnetic field will be given by the vector sum, but this diagram will look at different. For example, if this has reached its peak, we all know that magnetic field is basically equal to this, and we already know that this was equal to the line integral of uh, the line integral of the h was equal to the line integral of just let me check so I don't make a mistake. uh, h was the line integral of, just let me check in the book. Okay, sorry. I was the line integral of H, okay, H dot dl. So this was the net current, and we knew that all the magnetic field is produced by the electromagnet, and the electromagnet's main magnetomotive force was equal to Ni. Okay, so I basically relates to the magnetic field, the magnetic field intensity. The magnetic field intensity relates to the flux, and basically the total magnetomotive force is equal to Ni for a coil. So I plays a dominant role in the creation of the magnetic field, given the number of turns in a machine is constant, because you normally are not able to change the number of turns in the coil of your maybe ceiling fan motor or maybe your water motor. So it is known that N will be a constant and I will totally be determining the strength of the magnetic field. Okay, so now when we are feeding the three different phases with voltages and currents that are 120 degrees apart, so that means that each of the magnetic coils will also reach their peak at different points in time. So for example, when this one has reached its peak, you can see this one is already here almost zero, and this one will be somewhere in the negative direction. And when this one reaches its peak, this one has already gone below its maximum, and this one is also almost equal to zero. So if we consider, let's say, point A, okay. So at point A, when the first set of field is at its maximum, we are representing this as the first set of coils, the second set of coils, and the third set of coils. So when the first set of coil is at its maximum, corresponding to this diagram, okay, then we can see that the second one is almost equal to zero. Okay, at point we are considering point A. Okay, so this would have been an ideal situation if all the three phases, if all the three set of coils were fed with the same phase angle. But since we are feeding it with different phase angles, so when the set of coil one is at its peak, the second one is almost zero. So you can maybe think of it like this. Okay, so the second set of coil is almost equal to zero, and the third set of coil is in the negative direction and almost at its maximum. So this third set of coil is almost at its maximum but in the reverse direction. So we change its direction, so it's almost in the reverse direction. Okay, what happens at point B? If this was the situation at point A, now what happens at situation at point B? Okay, first set of coil has slightly reduced. The black one is the first set of coil. Okay, so we call this one, the red one is 2, and this green one is 3. Okay, so we can already see that the black one is already reduced a bit, so it is not as long, the vector is not as long as in the diagram for point A. Let's say this is the field due to first set of coils. And what happened to the second set of coil? Second set of coil, which was previously very low, almost equal to zero, now it has reached its maximum. So now 2 has reached its maximum. Okay, so 2 has reached its maximum. And what about coil number 3, which is green color? Green color is still positive, but it is reduced now. Okay, so it is still in the positive direction, but maybe the strength is almost half. Okay, so for point B, the diagram will look like this. Is everyone following me up till here? Okay, so we have three set of coils, but the three set of coils are also angular. They are having an angular separation. So their magnetic field vectors will always be having 120-degree separation. Plus, they are also swinging in their magnitudes as shown by this diagram. So if we represent the black with to represent black to represent phase 1, red to represent phase 2, and green to represent phase 3, as corresponding to these 1, 2, 3 labelings on the angular diagram. So at point A, we can see phase 1 is maximum. So that means the strength of the set of coils representing uh, this set of coils is representing the field, which is like this. It will be having a maximum value at point A. So let's assume its maximum was positive direction is as per this diagram. So its maximum positive value is in this direction. But when we look at B at point A, B is almost equal to 0. So we draw the second set of field. It is still in the same direction, but since it is almost equal to 0, I show it with a very small length arrow. And for the point corresponding to the green, the third set of fields, it is taking a swing in the negative maximum direction. So the positive direction was taken like this. So in the negative direction, I will reverse this arrow to represent the swing in the negative direction. When we consider point B, now B has a first set of coils has reduced a little bit. So I show it with a arrow with a shorter length. The second set of coil has reached its maximum now. So the arrow corresponding to 2 is shown with its maximum magnitude. And for the green one, we see now the green one is almost equal to 0. So we show the green one with a very small length. Is everyone following me? And at every point in time, we can find the resultant magnetic field by taking the vectorial addition of the diagram at that point. Is everyone with me up till here? Okay, I'm using English because of Abdullahi. If anyone has any problem, please confirm me on the chat window. Are you okay up till here? Okay, we can take another case for point C. Okay, let's say this is point C. What happens at point C? Okay, at point C, we see that the black arrow is also reversed and is less than its maximum value. So at point C, the black arrow, the field corresponding to the first set of coils is reversed and with a small magnitude. Okay, and for the red one, the second set of coils, it is also reversed. So the second one will also be shown in a reverse direction. The positive direction was this, so the negative direction will be this. So, and for the third set of coils 3, we look at the green field, and at point C the green field is almost equal to 0. So C is just located over here. Okay, C, no, the C is having a maximum over here. So it is 0. Yes, it is 0. So 3 will have almost no length. C will have almost no length. So C is just 0. So or the third set of coil field is just 0. So at point C, the resultant will only be due to the first set of field, which will having a reverse swing. Why it will having a reverse swing? Because it is fed with a AC current and AC voltage. So for the point when this uh, current is going in this direction and we use the right hand thumb rule, the north is showing like this, but after half cycle when the current will reverse, so the arrow will reverse its direction and corresponding to this north will come here and south will come here. Okay, so if we curl the finger in the direction of the red arrow, the north will be shifted from the left side to the right side. So this will happen for all the 3 set of coils which are being fed with the different phases. Because everyone with me up till here, anybody has any doubts? Okay, for Amir Noor it is clear, Anam Shafiq clear, Ehtisham is clear, everyone else is clear. Okay, so I take their feedback as everyone is clear with this. So we have 3 set of coils with an angular separation of 120 and their magnitudes keep swinging because they are fed with AC voltage. So the magnitude can also swing in the reverse direction based on the direction of the voltage, and based on the sine wave, it will have a varying magnitude. It will go from 0 to a positive swing here, again back to 0, then it will go to a negative maximum here, then again to 0, and this will keep on happening with all the 3. But at different points in time, they will be having different situation. So they can never reach the peak at the same time since they are fed with 3 different phase voltages which are 120-degree apart. Okay, so most of the students are clear with this. So now if I want to calculate the vector addition to find the direction of the field at any point in time, because we have to find what is the resultant effect, and the resultant effect is a rotating magnetic field, because I told you that when the magnetic field is rotating, the rotor tries to catch up with this field because of the Lenz's law, and it also starts to rotate in the same direction. So there is no relative motion, so that there is no d phi over dt. Okay, so EMF induced is equal to minus of d phi over dt. It is caused due to the change in flux, but it acts in order to oppose the change which causes it, and the change is the rotating magnetic field. So the rotor also starts running in the same direction as a rotating field due to stator. Okay, so we want to drive this rotating magnetic field mathematically. So how we can drive it mathematically? So now I know that we have 3 fields. Let's call the first field as BM. Okay, so we have 3 fields and the direction of the first field is this. Okay, and uh, angle is 0. First field angle is 0. Phasor is 0, but its magnitude is given by this sinusoidal voltage. So it will be basically, okay, I'm using red pen for the first voltage now. So it starts from the value 0. Okay, and when after 90 degrees it will reach its maximum, another 90 it will again go to 0, then it will start swinging in the negative direction. Okay, so its magnitude is varying according to this sine wave. It starts from 0, then increases in the positive direction, then again decreases in the negative direction. So its magnitude is not constant, it is given by this function. This function will take care when it is maximum in the one direction and when it is maximum in the other direction and when it is 0. Okay, so for the magnitude part, I take this function, And for the angle part, I already know that its angle is 0. For the second phase, let's take the green pen. Okay, for the second phase, I know the second phase is 120 degree apart, and angular also it is 120 degree apart, the second set of coils. So let's say the second voltage was like this. Okay, so I know that between the first voltage and the second voltage there is a phase shift of 120 degree. So its magnitude function is, for this one, its magnitude function will also be phase different. It is sinusoidal, but now it is phase different by 120 degrees, and its angle is 120. Okay, so I represent all the phasors, but now the phasors magnitude is a time varying function, and their angle is constant because of the physical construction of the motor. Similarly, I take the third phase. Let's take the black pen for the third phase, or the blue pen. Okay, so for the third phase, the angular separation between these two is again 120, and between the first one and the second one is 240 degrees. So the third phase is like this, and its magnitude will be a time varying function like this, because it is 240 degree with respect to the first one. It is 120 degree lagging with respect to the second one, but it is lagging 240 degree with respect to the first one. So it is this 240, and I know its angle is also 240. Sorry, I will call this angle is minus 240, and this angle is minus 120. Okay, because this is the reference line. This is minus 120 degree, and this is minus 240 degree. Okay, so there will be minus 240 and minus 120 over here. Is everyone with me up till here? Is everyone with me up till here? So all the three rotating the three magnetic fields, they have 120 degree orientation with respect to each other, and because of the construction of the coils, but their magnitude is a time varying function due to the three phases being having a phase difference of mutual 120 degrees. Is everyone with me up till here? Okay, anyone has any question, please tell now. Okay, anyone has any questions? Okay, if you have any questions up till this point, please write on the chat window. Are you clear, everyone? Okay, Anam is clear. What about others? Anam seems to be following my lectures very well. What about others? Anyone else having any problem? Okay, Yasir Ijaz, Usman Ali Khan. If Usman Ali Khan is happy, then I'm happy. The whole class must be happy, because Usman is always asking questions. Okay, so let's switch to the black pen, and let's use the eraser. Okay, now so the vector addition for the three fields will be first magnetic field, because I want to find the resultant effect. Okay, and the fields doesn't always look like this. Sometimes this arrow becomes small, sometimes this arrow goes in the negative swing, sometimes this arrow goes in the negative swing. So the angular separation for this magnetic field is always 120, but their magnitudes can do different funny games, as I told you in the last slide, because of this diagram. When one is at its peaks, second may be going 0, third one will be at maybe its negative peak. So we add them up to see the effect. So the first one is Bm sine omega t. Okay, this derivation may look very tricky to you, but it is actually very easy. Okay, so this is the first one, and we take this. This is the second one. Okay, and we know that the angle for the second one is also minus 120, and for the third one it is Bm sine omega t minus 240, and the angle is also minus 240. Okay, so the resultant must be the sum of this. We want to find the resultant. Okay, what is the resultant magnetic field if we have three set of coils, especially 120 degrees apart, and fed with three different phase voltages which are also 120 degree mutually apart? Okay, so the first thing to do is, let's get rid of the Bm. Since Bm is common, let's get rid of the Bm, take it common, and rub this from here, so we have less things to worry about. Okay, now we have got two gadgets, sine omega t minus 120 and sine omega t minus 240. So let's sort them out, that what is this equal to and what is this equal to, because we may be using it in our derivation. So let's do it on the bottom here. Okay, so if we have sine omega t minus 120, and we want to expand it using the sine A minus B formula. So you already know that the sine A minus B formula says sine A cos B minus cos A sine. Okay, so we apply this formula here. Sine omega t minus 120 would be sine omega t, and cos of 120, and cos of 120. Okay, first quadrant all positive, second quadrant sine positive, third quadrant tan positive, fourth quadrant cos positive. So minus 120, sorry, sine A cos B will be cos of 120. So cos of 120 is somewhere here. It will be equal to minus cos of 60 because cos is negative in the second quadrant. So this will be equal to minus half. Okay. And when we do minus cos A sine B, so it will be cos omega t. Okay. And sine B, which is sine of 120 degree. And we know that sine of 120 degree will be equal to plus sine of 60 degree, and plus sine of 60 degree is under root 3 over 2. Okay. So we have solved this one. Now let's do sine omega t minus 120, so minus 240. Okay, is everyone okay with this? Okay, so whenever cos is in the second quadrant, it will have a minus value, and when the sine is in second quadrant, it will have a plus value, and this minus was actually coming due to the derivation. Okay, sine omega t minus 240 will be sine omega t and cos 240, and 240 lies in the this quadrant, third quadrant, and in the third quadrant again the sign is again in the third quadrant the this is sine omega t cos 240. Okay, so cos is negative in the third quadrant, so it will be equal to minus cos of 60 degree, and minus cos of 60 is again minus half. Okay, and similarly minus cos omega t and sine of 240, and again sine is also negative in the third quadrant, so sine will be minus under root 3 over 2, but this minus of the formula will make it plus under root 3 over 2. Okay, is everyone with me up till here? Please respond on the chat window. Please respond on the chat window. Is everyone with me up till here?
Yes, sir.
Okay, everyone is with me up till here. So just let me check it. I have done it correctly. Minus, minus. This is minus and plus. Okay, very good. Okay, so now whenever we want to find the resultant of some vectors, so we can resolve all the components in the horizontal direction, and we can resolve all the components in the vertical direction, and then we can find the resultant. Okay, so we apply the same trick to these phasors since they are not exactly horizontal and vertical except for the first vector. So we can resolve their components into their horizontal and vertical. So the horizontal components will be in the direction of x vector, and the vertical components will be in the direction of the y vector. So let's resolve them. And when we have all the x's and y's together, we will find the resultant by adding them. Okay. So this Pm is outside. So this vector sine omega t, I can resolve it like this. Sine omega t cos of 0. If I want to resolve it in the x direction, and then sine omega t sine of 0 if I want to resolve it in the y direction. Obviously sine of 0 is 0, so its y component is 0. S can also be seen here, it is only having a horizontal direction, and cos of 0 we know is 1, so this cos of 0 will vanish, it will just remain sine omega t. Okay, so this cos of 0 is equal to 1, so in the x direction, and we can also get rid of this because it is 0. So we can say it is having only a x component direction which is equal to this. Let's come to the second one. In the second one, we have already found this derivation. So it is equal to this minus sine omega t minus under root 3 over 2 cos omega t. So we just substitute for this gadget, and then we have to do cos of minus 120 x bar for the x component, and cos of minus 120 will be how much? Okay, so cos of minus 120, so minus 120 is taking it into the third quadrant, So it will be equal to minus cos of 60. Okay, in the third quadrant cos, and this is a x component, and plus sine of minus 120. Again, minus 120 is taking it in the third quadrant, and sine is also negative over there, so it will be equal to minus sine of 60. So this will be equal to minus under root 3 over 2 y bar. Okay, okay, minus under root 3 over 2 y bar. And for the third one, again we put this derivation, which is equal to minus half sine omega t plus under root 3 over 2 cos omega t. Okay, and we now resolve this cos of minus 240. So minus 240 will take it into the second quadrant. If we go from here and minus 240 is here, so the horizontal component cos of minus 240 will be equal to minus cos of 60, which is again minus half. Okay, so this is the x bar component, and plus sine of minus 240. Minus 240 takes it into the second quadrant. In second quadrant, the sign is positive. So it will be equal to plus under root 3 over 2 y bar. Now quickly now multiply out these two brackets and give me the component of x bar and give me the component of y bar. Quickly, I'm waiting for you. Quickly, everyone, now multiply out these and give me the resultant uh, values for the x component and the y component. Okay, quickly, please. I'm waiting for you. Please do it quickly. Okay, I'm rubbing some useless bits so we can have more space. Okay, sorry, there is one more thing I want to tell you. When we are doing the vector addition, sorry, I made some mistake. So the original equation is like this: sine omega t. The first angle is 0. Okay, the second angle is 120 degrees. Okay, I checked from the book. Okay, so they take this sequencing. So for this one, the angles are not minus 120 and minus 240. The phase differences are minus 120 and minus 240, but these angles are 120 and 240. So corresponding to this, we will have to make change to this. So this 120-degree lies in the second quadrant. So in the second quadrant, cos continues to be negative, but sine will become positive. So this will come with a plus sign, and in the 240 degrees corresponds to the third quadrant. In the third quadrant, both are negative. Okay, so this will also come with a negative sign. Okay, students, please note this change. I was just a little bit wrong in the notations used in the book. The magnitudes are same what we did before, but the angular separation is 120 and 240. So for the first set of coil, it is like this. The second set of coil is like this. and the third set of coil is like this. Okay, and I think I switched the positions for the second and third coil, so we will use the same notation as the book. So don't consider this one as 2 and this one as 3. Consider this one as 2 and this one as 3. Okay, so I just swapped the positions of the second and third coil in the angular sense. Phase magnitude is correct. Okay, so now I want you to drive this equation with this sign changes corrections that I've just done before up for you. Okay, so if you proceed for this, how it will turn out. Okay, so Bm is constant. Let's collect the coefficients of x bar first. The coefficients of x bar are sine omega t. Okay, and there will be a coefficient of x bar when I multiply out this by this, so this will be 1 over 4 sine omega t. Okay, please students note this change that I just told you, that the second coil is here and the third coil is over here. Okay,
सर आपने किससे मल्टीप्लाई किया है?
okay, for the first term the coefficient of x bar is just this, right? And then we will have a coefficient of x bar when I multiply this gadget with this minus half. I will get another coefficient of x bar, and then I will also get a third coefficient of x bar when I multiply this by this. Is everyone following me? Okay, so for the second one, when I multiply this by this, I will get 1 over 4 sine omega t, and when I multiply out this one by this one, so I will get under root 3 over 4 plus under root 3 over 4 cos omega t. Okay, and then I will also have two more terms from this one. So when I multiply this by this, I will get another 1 over 4 sine omega t x bar, and when I multiply this by this, I will get minus under root 3 over 4 cos omega t. Okay, so these are just the coefficients of x bar, and the whole gadget is being multiplied by Bm. And now let's look at the coefficients for the vertical components, which is y bar. And the vertical components will be, first one will be when I multiply, I switch to a different pen color. Okay, where's the different pen color? Okay, red. So I will get one component of y bar when I multiply this gadget with this gadget, right? And the second one will be when I multiply this gadget with this gadget. Okay, so two terms from here and another two terms from here. The first term will be minus under root 3 over 4 sine omega t. Okay, minus under root 3 over 4 sine omega t. And then there's a second one when I multiply this with this. So this will be 3 over 4 minus 3 over 4 cos omega t. Okay, and then I will get two terms from here. First one when I multiply this one with this one, and the second one when I multiply this one with again this one. Okay, so the first term will be minus when I multiply this one will this minus and this minus will become a plus, and it will be under root 3 over 4 sine omega t. And when I multiply this gadget with this gadget, I will get minus 3 over 4 cos omega t. Okay, so when I analyze this, if I analyze this, then I see that in this derivation, this term and this term are getting cancelled, and in this derivation, this term and this term are getting cancelled. So the resultant would be okay. I hope you noted that change. I by mistake I flipped the position of coils 2 and 3. So I just told you about that change. So what happens now is let's switch to black. Okay, so when I add this up, I will get Bm, and the first term will be equal to 3 over 2 sine omega t x bar 1.5, 1.25, 1.5, and the second one will be minus 1.5, minus 0.75, and minus 0.75 is minus 1.5 cos omega t y bar. Okay, so again I can put the 3/2 common outside, so this will be equal to sine omega t x bar plus cos omega t y bar. And I know that in order to find the resultant, I do this square plus this square. Okay, so if this was ax and this was by, so the resultant will be equal to under root a square plus b square. So over here the values of a and b are cos omega t and sin omega t. So in order to find the resultant, the magnitude of the resultant shown like this, it will be equal to 3/2 bm sin square omega t plus cos square omega t, and this is equal to 1. This is a well-known trigonometric identity, so the resultant magnitude is equal to 3/2 bm. Okay, so the resultant magnetic field magnitude is this, and what will be its angle? Since I know this x vector is having a positive sign and the y vector is having a negative sign, so the resultant should be having a negative angle. Okay, the resultant should be having a negative angle, and what will be that negative angle?
सर आपने 3/2 कॉमन लिया है तो माइनस की साइन भी तो आएगी ना बाहर.
सॉरी माइनस की साइन अंदर ही रहेगी, यहाँ आएगी. ठीक है, ये वाली माइनस की साइन जो है ये मैंने सिर्फ 3/2 को कॉमन लिया. मैंने पहला वाला प्लस के साथ है, दूसरा वाला माइनस के साथ. दिस माइनस विल स्टे हियर, लेकिन जब मैं रिजल्टेंट का मैग्नीट्यूड फाइंड कर रहा हूँ तो इट इज दिस स्क्वायर प्लस दिस स्क्वायर, तो ये माइनस उस वक्त इनकॉर्पोरेट नहीं हो रहा. ठीक है,
सही है.
ठीक है. रिजल्टेंट का जब मैग्नीट्यूड है, सो इट इज वन कंपोनेंट स्क्वायर प्लस द सेकंड कंपोनेंट स्क्वायर अंडर रूट. ठीक है, और इसका जो रिजल्टिंग डायरेक्शन होता है वो क्या होता है? ठीक है, हाउ यू कैन फाइंड द रिजल्टिंग डायरेक्शन? द रिजल्टिंग डायरेक्शन इज इक्वल टू, इसका रिजल्टेंट कैसे आता है? इट इज इक्वल टू tan इनवर्स ऑफ वर्टिकल अपॉन हॉरिजॉन्टल. ओके, इसका रिजल्टेंट एंगल क्या आएगा? कैन एनीबॉडी फाइंड इट फॉर मी? इसका रिजल्टेंट एंगल है, इट विल बी tan इनवर्स ऑफ वर्टिकल ओवर हॉरिजॉन्टल. ठीक है, वर्टिकल कंपोनेंट ये था और माइनस के साइन के साथ, बिकॉज इट इज इन द फोर्थ क्वाड्रेंट. ठीक है, so it will come out to be like this. ठीक है, अब इसका जो एंगल है, इंस्टेड ऑफ पुटिंग इट लाइक दिस, लेट्स सी होता क्या है. ठीक है, तो लेट्स पुट द एंगल फॉर पर्टिकुलर वैल्यूज. ठीक है, इसका मैग्नीट्यूड तो अब कांस्टेंट है. ठीक है, पर्टिकुलर वैल्यूज पे हम इसका एंगल निकालते हैं. व्हाट विल बी द एंगल व्हेन ओमेगा टी इज इक्वल टू 0? व्हेन ओमेगा टी इज इक्वल टू 0, दिस कंपोनेंट गोes 0, sin of 0 is 0, and cos of 0 is 1, right? 1, but due to this minus sign, that means that only the vertical component will be existing and it is pointing downwards. So what will be the angle when the vector is downwards? The angle is minus 90. What happens when the value of omega t is equal to 90 degrees? When the angle of omega t is 90, this one will be equal to 1 and this one will be equal to 0. So it will be only the horizontal, the resultant will only be pointing in a